Hey guys, welcome back. Today we're going to be doing another combo of lessons 623 and 624, which deals with applications of logarithms and exponential functions. All right, so much like yesterday, what we're going to talk about in today's video, we're going to talk more about this regression stuff and the regression feature on our calculator. So we're going to kind of learn what regression does and how we can use it to build graphical displays and equations that model different scenarios. All right, so we're going to walk through that. It's going to be very similar to what we did yesterday. All right, so today's problem, today's scenario deals with our park rangers, our national park rangers, and one of their many responsibilities is to actually observe the wildlife and look at the populations of different animal species that live in the park. Right, and typically when an ecosystem becomes imbalanced, it's because one population of an animal becomes too big. All right, and to kind of balance that ecosystem, sometimes there are population control measures that park rangers will take with the animals that live in the park. Another thing that happens is you get invasive species, right? Species that don't belong in the park and can cause harm to those ecosystems. So the scenario here is there's a park ranger who discovered an invasive species of carp, which is a type of fish, and you can see a picture of that fish right here. Kind of an ugly fish, but they are all over the place, and they discovered it in one of the lakes. All right, now these carp go in and they tear up food supplies, they eat other fish, they do all kinds of things that are pretty destructive to the ecosystem inside of that lake. All right, so the park ranger grows concerned about this fish being present in the lake and decides to monitor the growth of the carp population. Now, sometimes you might find a couple carp in there, but they'll die off pretty quick, so you want to monitor the population and see if they are spreading or if they are declining in population. All right, so the ranger goes and does counts, and these were the number of carps that the ranger counted on the given days. So they collected data, looks like over a period of about a month, because it's about 29 days there, and then observed the number of the invasive carp that were in the lake. All right. So we're going to do the same thing that we did yesterday. We're going to enter this data into our calculator, and we're going to use the regression feature and the scatter plot to make some decisions about our model. All right, so to do that, we're going to go over here. We're going to hit this button right here, Stat, on our calculator. We're going to choose Edit, and that'll take us to the list screen. So these are all lists, and we're going to be working with list 1 and list 2. All right, so for list 1, we're going to enter in the number of days, right? So number of days will be list 1. And we would just enter these numbers into the list just like we see them in our problem. All right, and then we're going to put the number of invasive carp into list 2. All right, so you'll see I already got my data entered in here, but to enter in data, you just go to one of the fields, you type the number and you hit enter, and it'll put it into your list, and it automatically saves as you do that. Okay. So you can pause the video if you would like. You can take a couple minutes, put the data into your calculator if you want to follow along with this problem specifically, or maybe you're following along with your problem in MyOpenMath, which are going to have some slightly different numbers. All right, so hopefully you've got your data entered into L1 and L2. And so the next thing that we're going to do now is we're going to decide what kind of regression we want to do. Right? Are we going to do a linear regression, or are we going to do an exponential regression? So to do that, we want to take a look at the scatter plot. All right, so the scatter plot is simply taking these values, treating them as x, y points, and then plotting them on a graph. And once we have them plotted on a graph, we can look at the shape of the graph and make a decision about whether or not it's linear or exponential. All right, so I'm going to walk you through that here on the calculator. So to get a scatter plot built, we're going to go to the stat plot feature, which is right here above the y equals button. So you have to hit second and then y equals, and it'll take you to the screen where it says stat plots. Okay, we want to make sure that these are turned off except for stat plot number 1. All right, so we're going to go into stat plot number 1, we're going to turn it on, and then under type we're going to select the thing that looks like a scatter plot. So you'll see all kinds of different types of graphs that we can create. We want this very first one right here that is a scatter plot. Okay, then it's going to ask you where your x's and your y's are. Okay, so we put our x values, the number of days, into the x list, and we put our y values, which were the number of carp, into list 2. And then you can change the mark. If you don't like the dots, you can change it to squares or pluses or whatever symbol you want to do. And then from here, you're going to hit the zoom button and then option 9, which is zoom stat. And there we go. So we can see our scatter plot. This scatter plot that we see here on my screen is the same one that I have copied into your notes, so we can take a look at this, and hopefully you should be able to see that this is not creating a straight line. If this were trying to make a straight line, then we would say this is a linear regression, but since this one is curved, we're going to assume that it is exponential. Okay, so that tells us what kind of regression we want to do. That's why we like to look at that scatter plot. So now that I know I'm doing an exponential regression, we're going to use our calculator to find the regression equation. Okay, and this is the equation that typically fits our data. And it's really easy to do. We just hit the stat button. We go over to calc. We use that right key to move over to the calc menu. And then we're going to scroll down until we see EXP reg. And there it is. So we hit enter. And much like when we did our stat plot, it wants to know where your x's and your y's are. So you're going to put in L1 and L2, should automatically be entered in there for you. And then just hit enter. Do not put in anything for the next two options there. Just go right down to calculate and hit enter. And on your screen, you should get all of the pieces that you need for your equation. All right, so it should build an exponential equation for you, and it should be in this format. Y equals a times b to the x power, and then they should tell you what a and b are. Okay, so for our equation, our a value is 5.91. 9132. All right, if I round to 4 decimal places, times, and then I need my b value, so that's given to us right here. So we've got 1.0827 raised to the x power. All right. So there's our equation. We now have an exponential equation. Let's see how well it fits our data. So I'm going to go to y equals here. I'm going to clear this out, and then I'm going to enter in my new equation that I got here. Okay, so once I have it entered into y1, I can hit the graph button and watch this thing go through my data points. It should go very close through all of the data points. That's how we know we got a good equation from our regression. And as you can see, that regression equation that we entered went through all of those points very nicely. The data matches up with our curve very nicely. So this is a good equation to use to make predictions and answer questions. Now do keep in mind that the calculator uses different variables than what we started off with in our problem. So rather than using y, we would say f of t. Right, this was the notation that represented y, and it represents the number of carp that are in the lake. And then we would write the same numbers, but instead of raising to the x power, we raise to the t power. T is our variable instead of x. Okay. Now remember, the calculator doesn't really know what variables you're trying to use, so it just defaults to x and y. All right, so this is the equation that we would enter in to MyOpenMath to make sure we get that one right. Okay, so check your variables if you're getting it wrong. All right, so now that we have an equation, we can use this equation to make predictions, answer questions. So what we want to do is we want to predict how many carp are going to be in the lake on day 41. All right, so remember that the variable t represents the number of days, and f of t is going to equal the number of carp. Okay, so when they say predict the number of carp on day 41, they're giving us the t value. All right, so if I'm looking at my equation that I just built, they are giving us the 41, which represents this value right here, this t value. Okay, so I'm going to say f of 41 equals, and then I do 5.9132 times 1.0827 raised to the 41st power. And I can use my calculator to evaluate that one quickly. So I'm going to exit out of my graph, and I'll type this in and see what I get. Okay, so I got everything typed in. I just got to hit enter now. And it looks like we got 153.69. Just round to 2 decimal places there. So f of 41 equals 153.69. So in other words, the number of carp on day 41 is going to be about 153, maybe 154 fish, right? So we would say approximately 153 fish. Okay. So we're making predictions about what the population is going to be in the future. All right, very handy tool to make forecasts and things like that. Okay. So let's say it's determined that the number of carp, so if the number of carp in the lake exceeds 120, right, this is when the rangers are going to get concerned, because if the population of carp gets too large, it can do some pretty serious harm to the lake's ecosystem. So once they get past 120, we have some major issues going on in the lake. So the rangers typically want to know, well, how much time do we have to get these carp out of here before they start causing damage to the lake? So we want to figure out what day this is going to happen. All right, so again, remember T equals the number of days, F of T equals the number of carp, and here they are giving us F of T. All right, so if I'm thinking about my equation that we built, we have F of T equals 5.9132 times 1.0827 raised to the T. This 120 that they're giving us in the problem represents this part of the equation. Okay. So I'm going to plug that in. So we would say 120 equals 5.9132 times 1.0827 raised to the T. And since they want to know the day, right, it says on day blank, right? So we're trying to solve for this variable T, which represents the number of days. Okay. So I'm going to get that by itself. And I'm going to start by moving this 5.9132. So you saw this yesterday, right? Our goal is to kind of isolate the exponential part. So that means the 5.9132 needs to move over here with the 120. And since it's multiplication between those two items, we're going to divide to move it. Okay. The 5.9132s, they cancel out. I can go to my calculator and I can do this calculation pretty quick. Okay, so we get 20.29. Let's go 294. Let's go to 3 decimal places here. And we got 1.0827 raised to the T. Okay. So now this looks very familiar. We've seen these types of equations before. So if you recall from some of our previous solution methods, what we're going to do is we're going to take the log of both sides. So I'm going to take the log of 20.294, and whatever I do on one side, I have to do on the other side. So I'm going to say the log of 1.0827 raised to the T power. I chose a base 10. That's why you don't see any bases on the logs here. And now that I have put these into logs, I now have the power property available to me. And the power property says I can take this T, that's an exponent, and I can move it out front of the logarithm here. All right, so now I can rewrite this as the log of 20.294 equals T times the log of 1.0827. Right, and then the final step here to get T by itself would be to move this logarithm over here to the left-hand side with this logarithm. And again, since it's multiplication, we're going to use division to do that. So I'm going to divide this side by the log of 1.0827. And whatever I do on one side, I've got to do on the other. Okay, so that way these logs cancel out. And I'll finish writing the problem over here. So we're going to say T equals, right, because now T is by itself, these two logs divided, right? So I'm going to say log of 20.294 divided by the log of 1.0827. And this would be our exact answer, but we would most likely appreciate an approximation for this type of problem. So I'm going to go to my calculator. I'm going to actually divide those and get a decimal approximation. So I'm going to say the log. There we go. So I divided the two logs. I got 37.88. So we'll say 0.886. And remember, this represents the number of days. So we would say on day 37 or 38, right? So it's somewhere in between 37 and 38, probably closer to day 38. So I would say on day 38, we predict there will be 120 carp in the lake. So that gives the rangers an idea of how much time they have before these carp start doing some serious damage to the ecosystem in the lake. All right. All right, guys, hopefully you found that helpful. If you have any questions, make sure you let me know in the Zoom chat. Have a great day.